In this video, we will solve a mass balance equation problem. And so if you want, you can pause the video here and attempt the problem where you will be solving for N1, N2, and X. So let's get started. If you notice in this problem, we have everything in terms of moles except for water, where we have it in terms of centimeter cubed. We have it in terms of volume. Now with water, we know the density, and so we can relatively easily calculate N2. So let's do that first. So we have 40 centimeter cubed of H2O of water per minute, and we know the density of water is 1 gram per centimeter cubed. So 1 gram of H2O per centimeter cubed. Now this is the density, and with that we can easily calculate moles. So we know that the molecular weight for water is 18.02 grams, would make 1 mole. And so if you notice, we have centimeter cubed cancels, grams cancel, and we have moles per minute like everything else. And so once we calculate this number, we would get 2.22 moles of H2O per minute. And this right here is N2. This is one thing that we are trying to solve for. So we can box in this answer. And now we will calculate N1 and X and N3. Also, N3 is something that we need to calculate. Now, calculating N3 will be the next thing that we will do. If you notice, we have oxygen here, oxygen, nitrogen, and this is water, and this is also water. So we can do a balance, a mass balance with just water. So if you notice, N2 was 2.22 moles of pure water. So we could say that 2.22 moles is equal to N3 times this mole fraction. So times N3 times 0.05. And we can calculate N3 easily, and we would ultimately get that N3 is equal to 44.4 moles per minute. And so we can box in this answer. And now we can easily calculate N1. So we know N2, we know N3, and we don't know N1, and we don't know N1. So now we can get N1. So we could say that N1 plus 0.6 N1 plus N2, which was 2.22, is equal to N3. N3 was 44.4. So this is a total mole balance. Input, 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 output. And so with that, we can get N1, and N1 would equal 26.36 moles of air per minute, moles of air per minute. So we can box in this answer. And we can also calculate this one right here, 0.6 times N1. So 0.6 times this number would equal, so we can just say, 0.6 N1, and that's going to give us 15.82 moles of oxygen per minute. And so that is another answer that we have now. So now what we have this, this, this. We also have N3, and we just need to solve for X. So I'm going to scroll down a little bit. Okay, to calculate X, we can do a oxygen balance. And so one stream we had was 26.36 moles of air per minute. So 26.36. But with air, we know that the composition had 0.21% percent for oxygen, plus this stream was pure oxygen. This 0.6 N1 was pure oxygen. So we can just add it as 15.82 is equal to N3 was 44.4, which was our output. And we want to solve for X. So times X. And by doing so, we would get X is equal to 0.481. And that's all we need to do for this problem.